The second part of this presentation about laundry detergents covers different mechanisms involved in cleaning process. All right. In order to discuss mechanism of cleaning, we need to look at the components of washing process. There are surfaces, which are surfaces of the clothes and fabrics, soil type, different kind of soils, and the condition of the cleaning solution, temperature and water hardness, and of course the mechanical energy that is applied for washing. Cleaning consists of two processes, soil removal and soil suspension, and these soils are attached to surfaces by means of chemical bonds and physical adsorption. Type of surfaces, we can classify the surfaces by their affinity to the aqueous medium. They can be hydrophobic surfaces like surface of polyester fibers, nylon fibers that basically are oil loving, basically attract oily soils, and hydrophilic surfaces, which are kind of more attached to the aqueous media. By nature of surface, we can classify them as smooth, hard surfaces or impervious, like fabrics, and porous surfaces, like fabrics, cotton fabrics, polyester fabrics, and so on. Type of soils, we can have water-soluble materials, inorganic salts, sugar, perspiration, urea, pigments, metal oxide, carbonates, carbon black, fats and oils, animal fat, vegetable oils, protein, blood, egg, milk, skin residue, carbohydrates like starch, rice, potato, corn, and bleachable dyes like fruit juice, vegetable juice, and tea and coffee. And usually there is a mixture of these soils present on the fabric that needs to be removed. Each of these soils require a different mechanism and ingredients for their removal. In terms of water quality, key components are water hardness and water temperature. Water hardness relates to concentration of calcium and magnesium salts in water. Less than 50 ppm concentration is considered soft water. Above 200 is considered very hard water. And in between is a moderate hardness. Water temperature can be anywhere from ambient to 60, 70 degrees. Here are the mechanisms involved. The first part is wetting. Initial part of cleaning is that all surfaces, the surface of the fabric and soil need to be wetted. This process can be measured by measuring contact angle. And what happens is that the presence of surfactant and its adsorption at solid liquid interface, soil substrate interface, soil water interface, substrate water interface, reduces the interfacial tension and facilitates the wetting process. In terms of removing solid soils, this mechanism includes wetting and hydration, as discussed earlier, adsorption of surfactant at liquid, at soil liquid, substrate liquid interfaces, reduces the amount of work that is required to detach soil particles, and finally, adsorption of surfactants and the ions present in water solution create a negative charge that soil particles are repelled from each other. In oily soil removal, a roll-up mechanism is responsible for a majority of cleaning fatty, oily soils, basically absorption of surfactant at soil, on the surface of soil, and its interface with water, interface of substrate and water, results in beating up of the fatty soil particles and eventual removal of these particles. This is a schematic that shows this whole cleaning process. Initially, the soil particles, which are mixture of solid and liquid soils, minerals, and oily soils, are attached to the surface of the fabric. Initially, surfactants are adsorbed at surface of the fabric and surface of the soil, thereby helping detachment of soil from the fabric surface and then emulsifying that so that it can be discharged while washing powder. And finally, there is surfactant absorption at the surface of the substrate or fabric, and this basically by rinsing is removed.